right, so on to chapter 22. Please note that we are skipping a whole bunch of chapters here to get to chapter 22. Most of those chapters are not all that exciting anyways, so don't sweat it too terribly much. 22. So what we're going to jump to here is a short, relatively light introduction to business statistics. First off, what is statistics? To some degree, yes, statistics is numbers, but why do we use statistics? What's the purpose? What's the point? To prove a point? I don't know if you use them to prove a point, but you use them to manipulate or decide how your business is going to work. Why? How? What difference does it make? I mean, what would you do statistics for? It's not a rhetorical question. What would it be? What would they be? I mean, otherwise there's no point, right? I mean, what would we use statistics for? In other words, what's the basic statistic that you guys have worked with most of your life? Okay, so money, okay? So what do you worry about when it comes to money? I mean, you want to know what your monthly salary is. Is your monthly salary always the same? No. So what do you do to figure out, say, what your monthly salary is so that you can talk about it regularly? Do you say that it changes every month? No. You want to have one number that describes your monthly salary. What number are you going to use after a year's worth of collecting a salary? What are you going to do? You get paid X amount of dollars per month. Are you going to tell somebody, well, I got paid $1,200 one month, $1,500 another month, $1,300 the next month, $1,700? Is that what you're going to say? What are you going to say? If you have 12 numbers that say this is how much I earned each month for the last year, are you going to tell everybody those 12 numbers every time they ask? What are you going to do? You may add them all up and say, my annual salary is X number of dollars, but then they're going to ask you, but I want to know what you make monthly. You average them all out. Exactly. An average is a business statistic. And what do we use averages for? I mean, why would you say your average monthly salary is $1,300 a month when it's not going to be $1,300 ever? It's always going to be a number more or less than it. Because it simplifies shit, folks. Come on. That's the whole point of statistics, is to say, I have a whole ton of numbers, hundreds of thousands of numbers, but I want to describe them with one number. All right? So the whole point of doing statistics is taking large data sets and simplifying into manageable, I'll call them, numbers. That's the idea. So you're trying to figure out how much does it cost on average to produce a particular product that you're making, right? So let's suppose that you guys all open up your own restaurant and you want to know what are going to be my monthly costs on average. You're going to try and figure this out. Equally, you're going to try and figure out, well, how much revenue am I going to collect per month on average? And then you'll be able to say, well, this is what my average monthly profit is, because you need that to know whether or not you get to eat next month. And being able to eat is, mildly important, right? Yeah. True, but then you're eating your profits. All right, so that's right. So what we normally work with when we're talking about statistics, the first thing that we work with are measures of central tendency. The idea here is trying to figure out what one number best describes all of my numbers that I have. All right? And normally, the number that we're going to use for that is the average. The problem with it, though, is that statisticians don't like that word, average. If you say the word average, it sounds, yeah, average. Right? So we need to come up with a better name for it. Well, there are 3 M's that statisticians use to measure the central tendency, and the first one is called the mean. Mean. It's nice, good, strong, monosyllabic word, right? Mean. And what does mean mean? What do you mean when you say mean? Do you mean that you're mean, or does the mean mean something else? Sorry, I'm having fun. It's a little late in the afternoon. Folks, is just the statistician's way of saying, calculate the average, okay? Don't ask me necessarily why statisticians want to use the mean instead of the word average, but they do, so get used to it, okay? If you are going to start talking about statistical information, don't say average. That will make you sound like a neophyte. Use the word mean. It sounds cool. Again, I don't know. But the fact remains is that mean is the way you use it, all right? And how would you verbally describe how to calculate the mean? How would you do it?
By adding up all the numbers.
And then?
And then dividing by the number of integers.
They don't have to be integers, but yeah. So add up the numbers and then divide by the number of numbers. That's a killer sentence because it's mathematically accurate and you got to say the word number 3 times in the same sentence. That's good shit. All right, now, I'm not going to beat the mean to death too terribly much. It is just the average, folks. You've been doing it for your, probably most of your semi-adult life, so I'm not going to beat it to death. But what I would like to do is to show you a little bit about how the mean is talked about statistically. First of all, if the numbers that you collected in your sampling, right? So normally when you're doing statistics, you're sampling numbers. If it's salary that you're working with, the set of numbers is what's your monthly salary or yearly salary, if you want to figure out what the mean of your average salary is, whatever. X defines your set of numbers. When you put a bar over your variable, you are indicating that this is the mean of my data set. In other words, I took my numbers, added them up, and divided by the number of numbers. Okay? It is a very classic example of how statisticians use the mean, and they expect you, when you read papers or write papers, to know that this is what that means. All right? If they put a variable down with a line on the top of it, they're just saying this is the average of all of my numbers. Okay? They won't even say that that's what it is because it's assumed you know. All right? We need a little bit more symbolism. Since this is statistics, I'm sorry, you have to learn a little Greek. That's just the way statistics work, right? Greek is all over the place in statistics. So if you don't learn a little Greek in this class, you haven't learned any statistics. This is a Greek letter. Does anybody know which Greek letter this is?
I know this.
It's the 5th Greek letter. Sigma. All right? This is a capital sigma. what does sigma mean in statistics? Well, how many of you have used a spreadsheet program? You guys have all used one, right? Like Excel or Lotus or whatever, right? There's a button that has this symbol in it, right? What happens when you push this button? What is, it equals the, not the average, but the sum of everything. This symbol means add everything up, all right? And since the definition of the mean is to add up all of your numbers, this symbol should be around there somewhere, okay? So just so that you've seen it, this is how statisticians say, add up all of the numbers. So the little I is just what ties you into all of the numbers in your data set. X sub 1, where I is equal to 1, is your first number in your data set. X sub 2, if X sub 1 is the first, guess what X sub 2 is? It's your second number. X sub 3 is your third number, etc. Until you get to n, where n is the number of numbers. In general, folks, little lowercase n represents the number of numbers in your data element, okay? So this is how you add up all the numbers. What do you have to do to get the mean? You add up all the numbers, and then what do you do? Divide by the number of numbers. And the number of numbers, by definition, is n. So this is the way statisticians will write how the mean is calculated. Not really.
Is it supposed to look like that with the little eye under it?
Yep. The little I is what ties information to the actual data elements. The little I says that I is going to go from 1 to n, and you're going to add up the first, the second, the third, the fourth, the fifth. Sometimes the i's are taken out and they're not put in there, but it's really better if you put them in so that you have some connection to the two of them. But you are going to see this symbol again, so that's why I want to show it to you. And it's also so that you get a little bit of a feel for how to deal with this when it comes to spreadsheet programs, which you are going to use, either sometime in the future or you already have, okay? So sigma, it's the capital sigma, and it says add up all the numbers, divide by the number of numbers, bam. So you don't need to know the symbolism so much, folks, but it is a thing that I would like you to have seen so that if you see it again sometime in the near future, you will say, oh yeah, I remember Marshall doing something like that. And hopefully the other person who is talking to you will ring the bell that I started ringing right now. All right? All right, so mean, standard, one of these measures of central tendency. The second one is the median. Anybody know what the median is? Middle. Yeah, since the median is the middle of the road, the median in statistics is the middle number please note, when you go to grab the median, don't just look at the data set and grab the middle number. Order them first, okay? Because I will probably on the test give you your numbers like this and say, what's the median of this set of numbers? Don't just look at it and say, well, which one's in the middle? Oh, it's the 4. Order the numbers first, then find the number in the middle. So look at your numbers and say, oh, this is 1, 2, 3, 4, 5, 6, 7. Which number is in the middle? 4. Oh, so it was 4. All right? On the test, folks, it won't work out that way, just so you know, okay? That's an odd number of numbers, right? 7 numbers is odd. What happens if it's even? Does anybody know the rule? Average the 2 middle ones together, yes. So let's suppose that our elements are 1, 6, 8, 7, 5, 4, 2, 3. What's the median of that set of numbers? Again, don't just grab the 2 in the middle. Order them. And yes, I am doing this on purpose so that it makes it easier. What are the 2 numbers in the middle? 4 and 5. Right, so here, the median is the average of 4 and 5. So add 4 to 5, get 9, divide by 2, 4.5. So normally the median is a number in your set of numbers, but only if this number of numbers you have is odd. If you have an even number of numbers, your median may not be in your set. Okay? So know the 2 different cases to deal with when it comes to calculating median, when it's odd numbers versus it's even numbers. Now, why would we ever use that number? Does anybody know when we use the median? You guys have never seen the median used as a numeric value before. Let me give you an example of why you would use it. So let's suppose that we have a contractor who's building houses in a neighborhood. And there are currently 5 houses in the neighborhood. And the prices of these houses are, let's say, $82,000, $98,000, $88,000, $87,000. And then the contractor built his own house at the end of the subdevelopment. And of course, he built his house like a mansion. You know, it had turrets, and it had a moat, and the house was worth $500,000. So what I'd like you to do for this set of data is calculate what the mean is and calculate what the median is. What was the mean price of houses in this neighborhood? Even? All righty. What's the median price of a house in this neighborhood? What's the median? Yeah, 88,000. So, when a realtor goes around selling houses in this neighborhood, like so suppose there's a few more houses that get built, in the next couple of years, which number will she use when she goes to say, this is the value of a house in this neighborhood? Is $170,000 about the right price for a house in this neighborhood? I mean, what's the average price of a house in this neighborhood? I mean, the average is $171,000, but what's better number to say represents the middle better? Probably more like $88,000, right? The reason why this number is a better number than this one is because of this guy's, jerk house, right? This is what's known as skewed data. And it's why we use the median sometimes with the mean, all right? If you are ever going to have data where there's one or two elements in your data set that make your mean look screwed up, technically you're supposed to report not only the mean, but also the median. And in fact, right now, if you are a realtor and you are discussing houses in a neighborhood, you have to report the mean and the median to a potential buyer or seller of any house in that neighborhood. Because these two numbers could be drastically different, and this one is probably a better representation of it. All right? So realize that this is why we use the median and why it's an important number to use in statistics when necessary. All right? All right, so those are two of the M's. Third M, the mode. What's the mode, guys? That's the moat. Slightly different than the mode. Mode. It's just the most frequently repeated number. Now, why would this number be of any importance?
If all your houses are selling at 88,000, and you can keep selling at 88,000, you spread ones in here and there, you'll know that your houses in that neighborhood sell for around 88,000.
Yeah, I mean, this, again, if it's the most frequently repeated number, it's probably, if you were to pick those numbers out of a hat, that would be the number you would be most likely to pick, right? Now, generally speaking, though, when the mode is used is when the data that you're collecting is non-numeric, okay? You will use the mode as your measure of central tendency when your data is categorical instead of numeric. In other words, when you're gathering people's information, maybe GPAs, okay, for whatever, just for kicks and giggles, you sit at the front door entrance of Blackhawk one day and you ask people, what's your GPA? And you write it down. And the whole point is that you're trying to gather GPAs to figure out, say, what's the average GPA for a Blackhawk Tech student. Reasonable sort of thing to do, right? If you can't, getting people's GPA and finding out what the actual average is probably against the rules to get it from BTC itself. But if you ask people as they walk in and they give it to you, you could calculate the average and say, this is kind of what the average is. Now, when you do that, you are probably also going to gather other pieces of information, right? You're going to get their GPA. You may also gather stuff like what hair color were they? What eye color did they have? What gender were they? All of those sorts of things. All of that additional data, gender, eye color, hair color, is there a number associated with any of that stuff? No. So when you go to report your information and say that the highest GPAs are by people with red hair, if there were only 4 people that had red hair coming through, right, I mean, that's a relatively important thing to say. So you would want to say that the mode of hair color at BTC is, say, black hair, and that the mode of eye color is brown, and the mode gender is male, right? There's more men than women here, potentially. Honestly, I don't know if that's true or not. All right? But the mode is what you use as the central measure when the data is categorical instead of numeric. And folks, this one's easy to calculate. There are some caveats to it, though. If none of your numbers or none of your data repeats, there's no mode. Okay? So in this data element, if I asked you what's the mode of my numbers, you would say there's no mode. Okay? Don't tell me it's 0, because 0 is a wonderfully good number. Use the phrase no mode, period. Okay? In addition, you can also have multiple modes if multiple numbers repeat the most frequently in a data set, right? So if my data set is 1, 1, 2, 2, 3, 4, 4, my mode here is all 3 numbers that repeated the most frequently. In this case, 1, 2, and 4. Okay?
So you write your mode out like that, or can you put it in parentheses?
You can put it in parentheses too, that's fine. If you want to write it as a set, that's cool. Please be careful. What's the mode of this data set? 1 and 3. There are 3s and 3 3s. Even though 2 repeated, it didn't repeat the most frequently, so 2 is not a mode, okay? So the only trick to the mode is the not having any and the fact that there can be multiples.
So you can write that out, parentheses 1, comma.
Yeah, you could write this, the mode is 1, 3. That's fine. Yeah, it would be better in squigglies because then it's a set. The set of numbers 1 and 3.
Those are brackets, aren't they?
Braces. Brackets are square. Yeah. All right, so any questions about mean, median, mode? Okay, so let's do a couple of examples of them then. And my favorite example when explaining mean, median, mode comes from my experience at working in the festival season up in Madison. So there's a bunch of music festivals up in Madison every summer, and I tend to volunteer for some of the different programs around there in order to help out. And where I volunteer tends to be in the beer tent, pouring beers, because, you know, I'm a nice guy and I love to volunteer. And when you take a break while working at a beer tent, guess what you do? That's right, you count money. Or maybe you drink a little beer. All right, so anyways, there's no cash register at these places where I work. So I can't go into the cash register and punch in every sale that I make and have a record of all the sales that I make while I'm going. So in order to keep track of all the beer that I sell, guess what I do? How would you keep track of beers? Different, like say maybe there's 4 different beers at your beer tent, and ones you sell, because some of them are a different price, right? What would you do? Yeah, exactly. You tally them, right? So let's, since this is Wisconsin, one of the beers I'm selling is Miller, and that's $2. This is a cheap festival, by the way. Let's see. One of the beers I'm selling is Capital. That's $3. Let's see. Another one I'm selling. Give me another good one. Coors, okay. And this, we got to have a light beer. So let's suppose that that's $2.50. Okay, we'll put a woodchuck in there. And let's suppose we sold that for $4. Like I said, this was a cheap festival. We were going for quantity instead of profit. All right, so you're working these beer tents. What happens? The first group of guys that are coming up, they're all walking up with Packers shirts on, and they can barely cover their belly. What do they order? There's 3 of them, so they ordered 12 Millers. Because they needed 3 each. And they were only $2, so they're like, $2? Sweet! We all get 3. There were 4 guys, sorry. They each wanted 3. Or were there 3 guys and they all wanted 4? I can't remember. Could have been. All right, so then the next group that comes along is a very nice couple. They're very happy. They're very well dressed. And, of course, what do they order? A couple of woodchucks, right? Because that's what you do when you go out with somebody nice. You have a nice drink, right? Woodchuck, tasty, but not these beery things. It's flavorful. All right, and so you keep track as you're going, right? So, a couple of people come in and order Capital. Another group of people come in and order a Coors Light. You get a couple more woodchucks. You get another Coors Light. You get another Capital, another Capital. You get a big, huge run of Millers. And then your shift is over. And the whole point of keeping all these tallies is to make sure that the money you have in your pocket covers all the beers that you sold, right? Because in these festivals, there's no single till for anybody, right? Everybody gets their own till, and at the end of every shift that you run, you say, this is how many beers I sold, this is how many of each I sold, here's the money that goes to pay for all of that. And the cool part about it is anything over and above that, which you collected in tips, you get to pocket yourself. Again, volunteering at a festival, a very good thing, right? And of course, as you're getting tips, right, you're filling beers up appropriately and whatnot. And again, you also get to sample the wares as needed. Now, how am I going to figure out mean, median, mode? Because that's what I want to know. Right? That's what we always want to know. Well, what was the average value of a beer that you sold? What was the middle value of the beer that you sold? And what was the most common beer that you sold at this particular evening? Well, the way you get that kind of information is you create a frequency table. Frequency tables are the way numbers are normally represented instead of using these little tally mark things, all right? So you will make a frequency table of all the different beers that you were selling. So I had a $2 beer, I had a $2.50 beer, I had a $3 beer, and I had a $4 beer. And then the frequency is just how often did I sell that particular value, right? So I sold 16 $2 beers. I sold 7 $3 beers. I sold 6 $2.50 beers. And I sold 5 $4 beers. And again, realize that this represents a set of numbers that you could write out in detail if you wanted to, right? Because this says that 2 repeated itself 16 times, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Whew. Technically, that's what this is trying to represent, is this big, huge, long list of numbers that you don't want to have to write out, right? I mean, you don't want to have to do that. That's why you create frequency. Instead of creating a big, huge list of comma-delimited numbers, you say, look, here it is in a table. All right, so how are we going to calculate the average price of a beer I sold, or the mean? 2 times 16, because what you really want to do, I mean, technically you want to add up all the numbers, right? But you don't add 2 together to itself 16 times. You guys are more mathematically enabled than that. You will say that, I can just multiply the 2 numbers, and that will be the same as adding the number together to itself 16 times. Again, rinse and repeat down the row. 15, 21, 20. What do I do with those numbers?
Divided by the number of times.
So whatever this works out to be, 888. Do I divide this number by 4? Well, there's 4 beers. But yeah, but there's 4 beers, right?
Yeah, but the frequency of each one is different.
Very good. Frequency, right? Remember what you do to calculate the mean. You add up the numbers, which we've done, but now you have to divide by the number of numbers. Remember that that is defined as the frequency. So add up the frequencies. 34, is that what you said?
Yeah.
So that my mean is the sum of all the numbers divided by the number of numbers. This is money, so you know how to round it. What's my average? What's my mean beer value? $2.59. So a little bit more than a Coors Light. Uh-oh. How are we going to find the middle number? What's one way that you could do it that'd work? Lay them all out. That's absolutely right. You could if you wanted to. 2, 2, 2, 2, 2, 2, 2, 2, 2, blah, 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 blah. You could do that if you wanted to. Do you want to do that? No. Do you think there's an easier way? Yes. The way you do it when your number is even, what's 34 divided by 2? 17. Add 1 to 17. You're looking for the 17th and 18th numbers. The median, since this is an even number of numbers, is the average of these 2 numbers. Now the only question is, which are the 17th and 18th numbers? How many 2's are there? So from the 1st to the 16th numbers are 2. What's the 17th number? What's the 18th number? What's the average of 250 and 250? Please use the frequency table to your advantage, okay? When you have an even number of numbers, you're looking for the middle number, which is that number divided by 2, and the number right. And you know how many numbers get you to these values because you've got the frequency right here. Use that to your advantage. All right? What's my mode? 2. Because, of course, the one that repeated the most is 2, 16 times. Classic student mistake, folks, on the mode is to tell me that the mode is 16. Please don't do that. 16 is the largest number, yes, but always go back to the data to tell me what the mode actually is. All right? All right, so We're going to do another example like this. But before we jump into that, the other thing that we have to play around with before we move on to another example is that you should be able to make pictures from your data. And you should be able to read pictures from other people's data and interpret what it means. Okay, I'm doing this just to be safe. I would like to think that you guys already know how to do this, but I'm just being safe. Right? When you graph statistics, you can generate one of, well, we'll get to the third one, but we'll worry about that on the next class. There are bar and line graphs. If I asked you to graph this data, because of course if you hand this table to a manager and say, here's a representation of my sales, what are they going to do? They're going to look at you and say, oh my God, why did you do math? I don't want math. Give me a picture of what you really did, because I don't understand numbers. I only understand pictures. That's the way management works, folks. That's perhaps a little bit cynical on my part, but it's not too far from the truth. So please be able to frequency, beer, be able to draw one of the two or both, right? And then our frequency, let's go by, say, 4s. 4, 8, 12, 16. You should be able to draw me a bar chart that represents this frequency table, right? So draw a bar that represents how many $2 beers you sold. Draw a bar that represents how many $2.50 beers you sold. And please be able to, get close to the right spot. There were 6 $2.50 beers. Don't have this, you know what I mean. Just be cool. We sold 7 $3 beers, and we sold 5 $4 beers. Yeah, I know. Now, the only thing that I am going to point out, and the reason why I'm doing this, is that technically this graph is incomplete. The reason why it's incomplete is that the $2 beer is a Miller. And from this chart, I can't tell that. You need to be able to portray that information properly in the chart. Okay? So, in order to do that, create a legend, okay? So when you do bar charts, if there is more information to your data than just the numbers, you need to let me know about it, okay? Or whoever is going to be reading the statistics, they need to know about it as well. And so what you have to do is create some sort of a discernible legend that lets people know that the $2 beer is really a Miller. That the $2.50 beer is really a Coors Light. That the $3 beer is really a Capital. And that the $4 beer is really a Woodchuck. Your bar charts or your line graphs are not complete unless you have given me all the data associated with the numbers, okay? You could have said, well, what if I wrote down here Miller, Capital, Coors Light, and Woodchuck? If you use the words instead of the numbers, that's cool. But the problem is that you need to then tell me that the Miller was $2. in which case it would have to be in the legend. Okay? So the data all has to be there. Don't just think the numbers are the only thing that's important, because it's not. All right? That's the only thing I'm trying to point out here, because a legend is 50% of the data in a bar chart or a line graph. Okay? And just in case, if I asked you to draw a line graph for this, right, you guys would just I'm assuming I don't need to show you a line graph, right? Okay, anyways, please be able to do graphs, all right? All right, so let's see. We'll get to pie graphs. Pie graphs, this kind of data, it's not really that conducive to a pie graph, but you could if you wanted to. You could say that I sold 34 beers and that almost half of them were Millers, and you could do it. But we'll get to that next week. Don't worry about it. I want to do one more example of these and then call it a day. All right, so So one of the things for those of you who have or have not taken it, I give a weekly quiz, 6-point quiz. Yeah, I'm a bastard. I also assign homework too. I'm a nasty bitch, man, let me tell you.
You don't have a 10-page paper, though.
No, I do not. Egad. So, on these quizzes, since they're 6 points, you can get a score anywhere between 0 and 6. Here are the frequencies of these scores over the last couple of years of the quizzes I've been giving out. 20, 28, 14, 12, 5, 3, and let's go with 8. So this is a frequency chart that represents my scores. Find them for me. Start with the easy stuff, folks. What's the mode? Is that right? 405? has to end in 5. Oh, you mean after you divide. What's 405 divided by 90? Doesn't that go evenly? One, really? Oh, that's why I was going wrong. Okay. Okay, that makes more sense. 365. That sounds better. I wondered why it would look so high to me, too. I was like, what the hell? So then your 360, this is where you were getting the 405, right? Wherever I ask you to round it, hundredths, thousandths, again, this is one of those where the directions would tell you where to round the appropriate number. All right, now, what about the median? This is the hard one, or the hard-ish one. How many numbers are there? There's 90 numbers. So what numbers am I looking for? I'm looking for the 45th and the 46th numbers because half of 90 is 45. The 45th and the 46th number. Whatever those two numbers are, I need to average those two together. Well, the first 20 numbers are 6s. 21st number is a 5. The 48th number is a 5. What are the 45th and 46th numbers? 5. What's the average of 5 and 5? 5. So again, when you have your number of numbers, if it's even, you need to find the two numbers in between it. Note that if it's odd, add 1 to your number of numbers and divide by 2. That will be your middle number. So if for some reason this number was 9 instead of 8, and there were 91 numbers, you would add 1 to 91 to get 92 and try and find the 46th number to represent the middle or the median in this case. All right? And
So,
yes.
What if you were doing your scores from 0 to 6?
That's fine.
And then you went to find your median.
So,
You're still looking at
first to the 8th number, 9th to the 11th number, 12th to the 16th number, 17th to the 28th number, 29th, the 49th number, or whichever way it goes. It's going to get you the same way. So your 45th and 46th are still going to be inside of here equally as well, right? So it doesn't matter which way you go, up or down. All right, that's enough for today. We will finish chapter 22. Realize that tomorrow, or Wednesday, I guess, we will talk about standard deviation and variance as well as pie charts. Thank you. And I do have last week's if you want it. Christina. Audrey. Take it easy, Shane. So hopefully we will end a little early next week, although, knock on some wood. Is it snowing again or is it done? Oh shit. I hope so too. Oh crap. Oh, did you already?